Okay, Jason Morgan was the first person to recognize Yellowstone as a hotspot. So what's a hotspot besides a good bar? A hotspot is, so the standard model is a plume that rises off the core mantle boundary and works its way up to the base of the lithosphere, where it imparts a huge amount of basalt, typically called flood basalts. As the plate continues to move on, the tail of the hotspot remains fixed and produces a chain of islands, similar to the Hawaiian Islands. Here's Yellowstone. There's some problems with Yellowstone. The problem with the hotspot model for Yellowstone is, notice the Columbia River flood basalts are offset from the hotspot track. The hotspot track is also out of timing with the expected North American plate velocity. We can explain the head problem by the intersection with the downgoing Juan de Fuca plate. However, the problem with the timing is a bit more severe. The yellow represents volcanic eruptions. Problem is the rates that you do when you calculate those are 2 to 3 times the rate of North American plate velocity. The problem, of course, is that those are just guesses as to where those volcanic eruptions are. So what I've done is use the deformation field of the Yellowstone hotspot, created by the heat from the hotspot tail, to track it. And you can see the heat by the red, and the black dots are earthquakes, and it forms a nice parabolic shape. So the idea is that we can track the actual movement of the heat underneath the lithosphere by the position of the hotspot, by the position of the parabola at any time. So what I'm using is the displacement on faults, and what I had discovered was that faults, this is a particular fault I studied where you can see the steepness corresponds to the rate of displacement, that when the hotspot's nearby, the displacement rate's literally an order of magnitude to 2 orders of magnitude greater than when the hotspot's not there. So what I've done is gone into a number of different valleys, more than you can see here, and you can see the steep displacement rates that I've found. And then you can plot these up. The black represents the times of high displacement rates. And when you draw a line through that, it connects to a displacement, a North American plate velocity of 2.38 centimeters per year, which matches very closely to what we expect from the independent estimates of North American plate velocity. This means that the hotspot seems to follow the classic hotspot model, and despite a number of recent papers that have come up with creative ideas, we think the standard idea seems to make the most sense. Thank you.